Will be the last lecture on security policies, the third. Uh, if you recall from last class, we talked about sort of the decisions that were made early in the days of the internet, specifically the what we call the World Wide Web. And so Netscape was one of the earliest browsers, the first kind of mainstream browser. And so a lot of decisions that it made in the mid 90s govern browser policies up to today, although there have been some revisions to these policies. Okay, so last class we talked about the cookie policy that came in 94. And the next year in 95, Netscape also developed a policy for resources, in particular active content like scripting, and how to essentially isolate scripts from each other when you're going to weave together a website that has scripts that are loaded from multiple different sources. Okay, so the name of the policy is called the same origin policy. It arguably isn't the most it's probably not the policy that you would guess if you were looking at it. You probably would guess that maybe it works different than it does. And the reason I say that is because there were a lot of websites that were built that were vulnerable to a particular attack called cross-site scripting. And it seems that the developers did not understand the same origin policy. That's what sort of left it vulnerable. Okay, so just to review again, we have different resources. So we have meta content. So these are the headers. So cookies from last class are in the header. Then we have the actual content of the page. Passive content is basically things that's not code. So it's images, video, audio, the HTML file itself. And then active content is things that actually run. And things that run are a little more dangerous because they can do different things. The main thing that we'll concentrate on in this class is if you get JavaScript running, what it can do is it can change the content of the page that you're looking at. So it can overwrite, say, all the images and videos and audio, all the HTML, all that type of stuff on the page itself. What it can't do is it can't really break out of that web page and do something to your browser or do something to your operating system or do something to your computer. So we're not thinking about threats like that. Those types of attacks exist, but it's usually because there's some vulnerability in the browser or in the interface between the browser and say a plugin or things like that. So there needs to be an exploit there for that to happen. It's not the case that running JavaScript in a website should ever have any impact on anything other than the website that you're looking at. So once you close that tab or you navigate away from that page, then that JavaScript stops running. And so it should be isolated. We're going to assume that the browser is able to isolate JavaScripts just to the current page that you're looking at. But what browsers might want to do is they might want to limit it even further than that, we'll get into those details. Okay, so the same origin policy, what it says is basically, okay, well, I'll go through the details. So what it does is it sort of governs all the resources on a website. So let's say you go to a website, you download the main HTML file, and then you're supposed to, in order to display the website, you're supposed to load an image from somewhere else and a video from somewhere else, an ad library from somewhere else, maybe some JavaScript from somewhere else. And what we want to know is, are these resources isolated from each other? Okay. Now, if you're thinking of passive content, an image, whether, let's say you download two images, it's not really a meaningful question of whether they're isolated from each other because they can't look at each other anyways because it's not script, it's not running code. Okay, so the main thing that we're concerned with is isolating active content that is code. So because it's code, it can ask the browser, hey, show me the other resource that you loaded, right? And then the browser's gonna, it can at least ask the question because it's active content, it's code. Okay, and then what the browser is going to do is it's going to make a decision of yeah, I'll show that to you, or no, I won't show that to you. And the other thing scripts can do is they can say, can you rewrite that? So, can you change that resource? So these are the things that are going to be governed by the same origin policy. Now, when you go and visit a website, what the browser does is it writes down every resource, its source, like basically where it came from. So if you download a JPEG, which is an image file, where did it come from? If you downloaded other things, where did it come from? And that's called the origin. Okay, so what the browser will do is it will keep track of the origin. Okay, but how it assigns origins to things is something that we'll get into. It might be a little different than what you expect. Once you've loaded, you don't have to wait until you load them, but as you start loading resources, the browser maintains kind of like a tree structure called a DOM tree. And so everything with one particular, let's say that the website that you're looking at has loaded resources from multiple origins, then the tree is going to have kind of like a branch for each origin. The rule is that, just the capabilities of a script is that it's able to ask the browser to see what's on the DOM tree, and it's able to rewrite things on the DOM tree or add new things to the DOM tree as well. Okay, so that's what the script does. And so what the browser is going to do is it's basically going to say some of the tree you're allowed to touch, but you can't necessarily touch all of the tree. Okay, and so if you get a bad script, because it can rewrite the DOM tree, it can basically rewrite the entire website. So everything, every HTML tag, every image, every aspect of the website could get rewrote by the script, unless if we're trying to isolate the script from being able to rewrite the whole tree. Okay, so getting a bad script on a website that's running it's really bad. It's very damaging to at least the user's experience of what that website is. Okay, so what is an origin? So technically speaking, an origin is a triple. It's the domain that a resource was loaded from. It's the port number that it came over, and it's also the protocol that was used to load it. So the domain is the most important. The other two are maybe secondary. And then there's this override flag as well. We'll talk about that in a second, but forget about it for now. So for example, let's say the domain is test.pulpspy.com. Because it's HTTP, we put that into the protocol as well. And HTTP typically runs over port 80. So you don't normally see that. The browser doesn't show it to you. But if you want to, sometimes you see at the end of a URL, you'll have the domain and then you'll have a colon sign. And then you put in the port number before you start putting in the slashes. So you are able to control ports in URLs themselves. And then this is the override flag that we'll ignore for one slide. Okay, so this is an origin, and a different origin, it would be a difference in any one of these three or technically four elements. So if this switched to HTTPS, it's not the same origin. If it's a different domain or subdomain, it's not going to be the same origin. If it comes over a different port, it's not going to be the same origin. We'll give some examples in a second. Okay, so the same origin just means it's identical. Okay, so the source that you got something from is identical, and the same origin policy is going to say something about things needing to have the same origin. Roughly speaking, it's going to say that if, say, you load JavaScript, it can touch any other resources that was loaded from the same origin. Okay, if it's from a different origin, it's not going to be able to cross over and touch it. One thing you might want to do is you might want to change the origin that you were that your resources are loaded from. Okay, so for example, let's say that you're loading resources from test.pulpspy.com, and you want the origin to appear in the user's browser as just pulpspy.com. Okay, so you can change the origin. The way that you do it is you sort of override the origin that you were assigned. And what you're allowed to do is you're allowed to go up. So if you're a subdomain, you can go up to a domain. If you're a subdomain, you can go up to a subdomain or to a domain. But you can't go all the way up to a top level domain. So you can't say, I want my origin to be all of .com, and I want to be put into I want to have same origin with any resource that was loaded from .com. This is similar to in cookies, where you also can't scope a cookie to a top level domain like .com. And the reason is it's just too unwieldy because it would match so many different resources. So how you would do it is you would say set document.domain equal to pulpspy.com. This would be allowed if you are pulpspy.com or if you're any subdomain of pulpspy.com. If you tried to do this, say on canada.ca, and you just said, hey, I want my document domain to be pulpspy.com, the browser would not let that get set. Okay, so it would give an error. Now, when you override the domain, then it flips a flag to be true or false. Okay, so what it will look like is when I override it, it's going to be pulpspy.com, say it's over HTTP and port 80, and now this override flag is true, whereas before it was false. Okay, so this just indicates that it was true. And so what that means is that resources that were actually from pulpspy.com can't interact with resources that were from a different domain, but sort of overrode their domain to match pulpspy.com. Okay, so it's kind of a safety feature. Okay, and so if you do this overriding, then you're only the same origins as every other thing that also overrided as well. So if they didn't override, then you're not going to match with them. So let's see some examples. So the first two, we'll compare everything to the top. So is the first two the same origin or not? Okay, so the protocol is the same. They're both HTTPS. The domain is the same. Okay, they're both users.encs.concordia.ca. The path is different. So everything after the slash is different. Okay, so they're not the exact same URL. Okay, but remember in the origin, we just put the domain itself. So the domain is the same, even if the path is different. And so because the protocol is the same, because the domain is the same, we don't say anything about the port. And so the port will be the default port, which is for HTTPS is 443. So in this case, they're going to be the same origin. What about the next one? So the next one is users.encs.concordia.ca. So the domain is the same. However, the protocol changed. So it's no longer HTTPS, it's HTTP. Therefore, they're not going to be the same origin. Okay. This one, HTTPS CISE.concordia.ca, it's a different subdomain. So users.encs.concordia and CISE.concordia.ca, they're different. So the first one will not match the fourth one. And the first one and the last one will also not match, again, because they're different. Now, in this case, it's a parent domain. Okay, so it's encs.concordia.ca. But for same origin policy, what we want is it has to match exactly. So it has to be the exact same subdomain. Okay, so the first one won't match the last one either. So of all the ones on the slide, the only one that matches the first line is the second one. Everything else are different origins from each other. Now, let's say that we do want to match the top one and the fifth one. They're close. They're almost the same. It's just that this one is a super domain of this one. That's where we can use the override feature. So here, what I could do is I could set document domain to be, even though it's users.encs, what I could do is I could set the domain to be encs.concordia.ca. Okay, so that's fine. Now, because they're both over HTTPS, because they're both going to encs.concordia.ca, because they're both over port 443, which we'll assume is true even though it's not shown, it looks like they should be the same origin at this point. However, remember the catch that we have that override flag. So they're still not quite the same because the top origin will be HTTPS encs.concordia.ca. Sorry, this is a typo. It should say 443. But here the flag will be set to true because we overrode the domain. Here we did not override the domain, and so the flag will be false. So these documents, they can't talk to each other, or resources across these two origins can't talk to each other. Okay. Now, usually we do this because we want them to talk to each other. That's the whole point of overriding. So there's a simple fix. The fix is that encs.concordia.ca also overrides its domain. Okay, so it also sets document.domain to be encs.concordia.ca. You might think this is pointless because it already had that origin and we're just setting it to be the same origin. Okay, why are we setting it to be the same origin? Well, what it's going to do is it's going to flip this flag. Okay, so the flag is going to go from false to true. Now it's going to match the two, and now your resources can talk to each other. Okay, so there's a lot of grief when you're trying to get resources to talk to each other. And you see a lot of times if you go on, I don't know, Stack Overflow or something, everyone's like, just, the first solution to try is always set document.domain to like the highest level that it can be, which would be concordia.ca. So if you do that on all your websites and you always just set it to concordia.ca, then everything will talk to each other. But there's also the security consequence of nothing's isolated from each other anyways. Okay, so sometimes maybe you don't want resources to be shared, even if they're within the same domain. They're just different subdomains. And so it's a sort of security usability trade-off, usability from the developer's perspective. But anyways, it's very common for websites to just set document.domain to be the highest that it can be, the domain itself, and just run that on every website. Okay, now we're going to go through different ways that you might have, say, JavaScript running on your website, and we'll think about what the origin is. Okay, so I have some JavaScript. I'm at concordia.ca, some website there, and I want it to run. Okay, there's different ways that you can put scripting into a website. Okay, so the first way that you can do it is you can just write it in line. So in the HTML, there's a script tag. So you can open the script tag, and then you can just write your JavaScript, and then you can end your script tag. Okay. So what would the origin? Now this JavaScript is a resource. Okay, so it's considered a resource, so it's going to have its own entry. This code itself will have its own entry in the DOM tree, and we're going to assign it an origin. So what origin would we assign it? So you can think about it, but probably don't have to think too hard because there's not really two different answers. I mean, we're on concordia.ca. The script is embedded in an HTML file from concordia.ca. It's clearly concordia.ca. So that's fine. So the origin in this case would be, I didn't show the whole origin, but it would be HTTPS would be the protocol, concordia.ca would be the domain, 443. We didn't do any overriding, so that flag could be set to false. Now, another way to load a script is usually inline. We don't like it. The reason we don't do inline scripts is you usually have a bunch of pages that are going to share the same script. Okay, so like say it's like some I don't know what it does. It does some little thing, but you might have 100 like different pages within your website, and you're running this same script on all of them. Now imagine that you want to change the script. Say some simple change, you just got to change one line of the script. But what you have to do is you have to go and change it on all 100 of those pages. Okay, so it's a lot easier to just host your script somewhere. So for example, let's say it's at concordia.ca/lang.js. And then what you can do is in all your web pages, you can just call that script. Okay, so this is better. Okay, so then what about the origin here? Okay, so concordia.ca is the website that you're on. It's instructing your browser to go to this place and get this JavaScript and load it. Okay, so the origin, in this case, again, there's not really much of a choice, but the origin's either attached to the website that's giving you the instruction to go find this script, or it's attached to the place that you're actually getting the script from, which in this case is concordia.ca. Okay. Now, because they're both concordia.ca, there's not really a question here. In either case, the origin that's going to get assigned is concordia.ca. Okay. But what if it's different? So what if we call a script and it's not hosted at concordia.ca, say it's at github.com. What origin do we assign it here? Okay, so we call this an embedded cross-site script. Okay, embedded refers to the fact that we're linking to it rather than writing it out in line in the actual HTML of Concordia's page. Cross-site refers to the fact that the script is coming from one place, GitHub, and it's being put into a website that's a different website, which is concordia.ca. Okay, so that's why it's cross-site. And then script refers to the fact that it's about JavaScript. And generally, we don't really think too hard about, like, say if it's an image that gets loaded from another website or things like that. Like, again, we don't need images. We don't really need to think about isolating them because they can't ask to see other things because they're not scripts and they can't run. So it's really, really important, though, to think about what we're going to do with scripting. Okay, so what's the origin going to be in this case? All right, so think about it for a second. Now, there's two answers, I guess. So one is it's coming from GitHub, so the origin is GitHub. The other way of thinking about it is I'm sort of embedding it, right? This word embedding it. I'm embedding it into concordia.ca. So even though it's coming from GitHub, maybe the origin should be considered concordia.ca because it was the origin of the request to get this script. Okay, it's not the origin of the script itself, but it was the origin of the instruction to go in and find this script itself. Okay, so you can see maybe arguments either way. You could imagine that Netscape back in the 90s might decide one way or another. Okay. But the way they decided is actually the one I think that makes the most sense, but it's not the most intuitive. So the origin of this that will get assigned is that of concordia.ca as opposed to github.com. Now let's think through why that is. Maybe that surprises you. If it does, you know why there were cross-site scripting problems for decades, because most people would assume that this isn't the case. Okay, so the mental model for this is what this command does is it says, go over, get this lang.js file. Here's where it is. It's at github.com. But what I want to do is what you're telling the browser to do is just copy and paste the code out of this file and make it just as if I wrote the code myself on my website. So I wrote it in line. I had script, and then I have a copy and paste of the code that's sitting on this file, and then I end it with script. We saw in the first example that when we have inline code, it's given the origin of the page that it's running on. And so what we're saying here is that just because GitHub happens to be hosting this code, it's no different, right? It's just like you copied and pasted that code, and now it's running in the context of concordia.ca. Okay, so when you load cross-site scripts, they're given the same context as the website that is doing the loading of them itself. Okay, now this is important because what that means is that this script from GitHub, it kind of has all the permissions of a script of concordia.ca, which means it can see all the resources that were tagged as origin concordia.ca that are being displayed on this website, and they can overwrite it as well. Okay, so they can change it. So basically they can rewrite the entire page. Okay, so if you get a bad script and you call it and it starts running on in the context of your website, it can essentially rewrite it. Now, it's not rewriting it on the server. It's not like your web page is changing it. It's just rewriting it in terms of what the user is seeing in their browser. Okay, so but it's effectively the same thing. I mean, if the user's seeing the wrong website, it doesn't really matter whether it was rewritten browser side or if it was rewritten server side. Other than if it were rewritten server side, it would be more permanent than if it were rewritten browser side. Okay, so yeah, so what it can do is it could change the appearance of anything. It can ask to see cookies, although there's some red tape about this itself. And then it can do things like it can log different input fields. So like say there's a username password. If there isn't, it could create it, right? So it could create a field for username password. And then the JavaScript could say, okay, every character by character that's being typed into this password field, I want you to send it. I want you to make a copy of that and send it to a server that the adversary controls. Okay, so getting a bad script running is really bad. Okay, now here's another example. So let's say that we have concordia.ca, okay, and we want to do one of those like Facebook like buttons. We saw them before. We talked about cross-site requests, and so what we want a like button, and if I click the like button, I want it to actually change my Facebook profile. So it needs to somehow be linked to Facebook itself, and maybe there's some information like how many of my friends on Facebook liked this article before, and that's being displayed to the user. Okay, but we also don't want Concordia to know about our friends on Facebook. Okay, so what we want to do is we want to isolate the two. Okay, so the way that we might try and do this, or one way that we could try and do it, is through an iframe. So concordia.ca will load an iframe, and it will say who gets to load that iframe. So it will give control of that iframe to facebook.com. Okay, and then Facebook will send down some HTML, and that HTML basically governs everything that's inside of this iframe. And that HTML can do whatever it wants. It could load more JavaScript, it could load images, load videos, it can do whatever. Okay, say it loads some JavaScript. So the JavaScript is now running inside of the iframe. Okay, so what origin do we assign this JavaScript? And the answer is, this is sort of maybe what we wanted in the previous slide, is that this will give origin facebook.com. Okay, so an iframe is kind of like a mini website. Okay, so the origin inside the iframe can be different. It's assigned basically the origin of whatever is loaded when you load an iframe, whatever domain protocol you're pointing at. That's the origin of the iframe. Okay, so if you want a website where things are isolated from each other, essentially you have to use iframes. Iframes are the tool that you use to isolate resources. So if Facebook is running scripts inside the iframe, it can't like reach out of it and ask about or to see or to change any of the resources that are loaded in Concordia's website, and vice versa. So if Concordia is running scripting outside of the iframe, you can't reach into the iframe. For example, you might say, I want people to like my article, so I'm going to load like a like button from Facebook, and I want to make sure the user clicks on it. So just with JavaScript, what I'll do is I'll sort of reach into the iframe and click the like button. So you can't do that. So the iframe is the barrier that stops those actions from happening. Okay. So Concordia, it can choose to load the iframe, but once it loads the iframe, it gives complete control over everything that's inside the iframe to whoever it loaded, whatever source it specified for the iframe itself. Okay, so it cedes complete control to facebook.com. Okay, it can get rid of the iframe. It doesn't have to load this iframe. It can change who the iframe points at. Okay, so but once it says, here Facebook, here's a spot on my website, you can do whatever you want in that spot. It has no control anymore over anything that happens within that iframe. Okay, that's solely on Facebook. themselves to govern it. Okay, so this is how we isolate resources from each other. Now, sometimes you might want to pass messages or data back and forth. And so there is, with JavaScript, you can do it. But what happens is both ends have to override the fact that it's isolated with a special post message protocol. And so if Concordia overrides it, but Facebook doesn't, it can send the messages, but the browser won't deliver it. And then vice versa, if Facebook allows it, but Concordia doesn't, it can send messages, but the browser won't deliver it. And if they both override it, then through JavaScript, they can pass messages back and forth. Okay, so yeah. Now let's think about cross-site scripting as an attack. Okay, so because this mental model of, scripts that get loaded into a website run with the same context of the website itself, that seems like there's some surface area for vulnerability. So attacks are going to be things that exploit it. So there's a couple ways of doing it. Here's some simple ways, and then we'll go to some complicated ways. So a simple way would be if I'm able to somehow change the JavaScript file that's being hosted. So GitHub is a code repository. Maybe I get like the login credentials for a library that's very popular that lots of websites use. If I'm able to change it, then my bad script gets run on every single website that's loading the script from this particular resource. It's given the context concordia.ca. Okay, so hacking a popular JavaScript library, you can do a lot of damage with that. Another thing would be if, let's assume for a second that this script were loaded over HTTP as opposed to HTTPS. Okay, then what the adversary could do is they could, if they were in the middle, they could modify it in the middle. All right. And so you could intercept it, you could change it. And this is why back in when we talked about HTTPS, we stressed the idea that browsers will not allow scripts loaded over HTTP anymore. They will just block that script from loading. And so the reason is it's so dangerous because anyone in the middle, they can modify this script. And once it starts running, then it can modify the complete the user's experience of the complete website. All right, another common kind of cross-site scripting, it doesn't really work that much anymore, but this is how it would work, is let's say you have like a profile on some website and you're allowed to put fields in, like I put my name, I put my, a biography of me, bibliography, sorry, I should say. And then here for my location, instead of saying, say, Montreal, what I do is I put in the command script. And then the tag script, I write some JavaScript, and then I close it. Okay, so I'm embedding an inline script into a text field that I control. Then let's say you come and you visit my website. Then when your browser hits the point where it's supposed to display my location, the idea here is that maybe the browser gets confused. As it's parsing that string, it realizes, oh, there's a command here, an HTML command, and or tag, I should say. But I need to execute that. Like this isn't script to be displayed. This is a tag that I'm supposed to execute. So I'm going to consider that a script, and then I'll run the code that's inside of it. Okay. So then every user that goes to this website to visit my profile website will end up running my JavaScript. What context is this JavaScript running in? It's running in the context of the website itself. So Twitter or x.com, it's running in that context. And then any permissions that you might have that the user, so you come to my profile, you look at my profile, then what I could do is with my JavaScript, because I'm running in the context of Twitter, I could start to maybe make changes to your profile itself or make you tweet things that you didn't want to tweet and things like that. Okay, so we call this, okay, first off, a precondition is that the browser does have to confuse data with code. Okay, so this should be data that's just displayed. And even if it was written this way, it should just write out the words, bracket, script, bracket. But we're relying on the browser to not be able to consider this to be text to be displayed, but actually to get confused. We call it persistent cross-site scripting because it's stored on my profile. I'm the one that's storing it. And it doesn't really work that well anymore because we're really, really careful about input fields these days. Okay, so what anyone who builds a website, anytime you take some data from the user and you're going to store it and display it to other users, you're going to probably use libraries and frameworks to do that. You're probably not writing the HTML from scratch yourself. And those frameworks are going to do all sorts of things to make sure that the browser doesn't confuse data with code. And it can do simple things like, for example, it will not allow a triangle bracket. So that it will be like an invalid character. So you can't even or it will look for, a tag like script, and it won't allow that tag and things like that. Okay, so it will do some things to make sure that it's not confused for code, and it will do other things to just make sure that anything that looks like code isn't permitted to be entered in this text field at all. Okay, so anyway, so this problem, they didn't solve the root issue, but they solved it by just doing a lot of sanitization of all input fields that a user may be able to use. Now, I'll tell you one story about this. So in the early days of social media, this attack did work. So there was a website, I might have the details slightly wrong, but I recall it being called MySpace. It was kind of like a social media website, before the kind of modern ones that we have today. And so this attack was possible. And so what someone did is they wrote a script, they put it on their profile, they got some people to visit the profile, it started running the script, and then they were able to use cross-site requests in order to instruct the user who is running the code to basically friend this person's account. So that this person, the hacker, the adversary, became the friend of this person. And also, through cross-site requests, they were also able to make the user that had visited the website change their own bio so that it would also have a copy of the malicious script. Okay? And so basically, imagine 5 people go and visit this one profile, they click on it, then now all of a sudden they have a copy of the bad script. And so everyone that goes and visits one of those 5 people's profile, it recurses. They end up with the bad script as well. And so the bad script just basically ended up it took over the network. So essentially everybody had it within. And there were some problems with performance and things like that in terms of what it did. And if I'm not mistaken, I think the person who did it was caught, and it was one of the early cases of hacking. But I'm a little fuzzy on those details. Okay, let's consider another kind of attack. So let's say that we let's just look at this URL. So there's a URL, https google.com/search. There's a query. The search query is script code, close script. Okay. So what happens if you click on this link? What happens if you click on this link is that Google will show you the search results for this search query. It's kind of a weird search query. Maybe there's not going to be a lot of results for it, but it's going to show it to you. Okay. Now that in and of itself isn't dangerous. The URL, the fact that there's JavaScript in a URL, it's not like your browser is going to confuse that with code. It's not going to say, oh, I need to execute this because it's in a URL itself. It's not even in the content of the website itself. Okay. But what could happen is, let's say the adversary tricks you to click on this link. Maybe they give it to you by email or something like that. And when you click on the link, again, it shows you the search results. Maybe there's no search results. But what Google might do, what they often would do, is they would say, sorry, there's no results for, and then they're going to repeat the query in the website itself. Okay? So they're taking something that was in a URL and they're sort of copy and pasting it into their website. And they're saying, sorry, there's no results, or there's 10 results, or whatever the number of results are, but it's for this particular search query. Okay, so the thing that was in the URL gets reflected into the website itself, and now it has the potential to be executed. Now that it's sitting on the content of the website, when Alice's browser parses the website and it hits that line, it has the potential for confusing that what should be text, and it might think, oh, that's code. Now I see that there's a script tag. I need to treat that as a script and execute the script itself. All right. So so the search term gets written out into the content of the website itself. We call it reflective cross-site scripting. It works in the sense that the reflection does happen, right? So for example, here I just made something up, and you can see that in the content of the website it does repeat it. So it does say there's results for this particular script here, okay? But what happens is that this is coded up in a way that that there's no way my browser is going to confuse this for a script that I'm supposed to execute, okay? So that's on Google, like for having good security. All right, so but anyways, in early days, websites like Google were not expecting this. They didn't know that they had to necessarily sanitize these kinds of fields. And so these types of attacks worked for a while. And there was a sort of time period where a lot of people who had social media accounts, they would think that their social media account got hacked because they would go visit it, or one of their friends would be like, why are you posting a bunch of advertisements? And they would go over to their profile, and there was a bunch of ads sitting there. And so they thought, oh, I must have got hacked. Someone hacked, meaning in this context, someone guessed my password or broke into my account. But really what was happening was it was just reflective cross-site scripting combined with cross-site request forgery attacks, where someone was clicking on a link, and then they were being tricked essentially into running some JavaScript, and then that JavaScript was posting things. The JavaScript wasn't able to fetch their actual password itself, so their accounts were still safe. Once they navigated away from the website, there was no control over their accounts after that. All right, now those are sort of two different variants of cross-site scripting, or three if you want to count the just like hack a popular JavaScript library. So there was reflective, there was persistent. When you take a course on network security or web security, it's a web thing, but it usually gets put into a network security course, you're going to see maybe 20 different variants of cross-site scripting. Okay, so there's lots of different ways of executing it. And some of them are really simple. So the ones that we saw are relatively simple. Some of them get really, really complicated. And so my goal here isn't to show you every kind of cross-site scripting attack. You'll see them in other courses. My goal is just to show you why the same origin policy, was confusing and how it led to these particular attacks. And the other thing I want to show you is that the adversary will not, just because something's complicated to do, it doesn't bother the adversary. The adversary will do the most complicated thing possible if it works. If they can make something work, then they're going to do it. So I wanted to show you one other kind of cross-site scripting attack. And the only reason I'm actually showing this to you is because it's kind of on the more complicated end. So I want to give you some of the simple attacks, and then I also want to give you some of the more complicated ones, just so that you can see that full spectrum, but we won't fill it in with all the attacks that are in between. Okay, so this is what an elaborate cross-site scripting attack would look like. So imagine that you have a web page, and the web page allows you to, again, supply user-supplied inputs. Okay, so for example, here I can type in my email address. This is somewhere I could stick some JavaScript. I could save it, And if I put JavaScript here and browsers confuse that for HTML that they're supposed to parse, then they'll end up running that JavaScript. Okay, so this so far is just persistent cross-site scripting. It's exactly the same. The twist is that some profile things that you set are displayed to other users. You have to display it to another user, otherwise you're just attacking yourself if you're the only person that can see it. And some fields are exactly things that are only shown to you. So when I'm logged in, I can see the email that I registered, but it's not part of my public profile. Okay, so what happened when cross-site scripting became like sort of a predominant way of attacking websites is that they got rid of all the persistent cross-site scripting attacks by really sanitizing all of these input fields. Okay, but some websites got lazy and they said, well, you know what, there's a bunch of fields that are never part of anyone's public profile. Like nobody would ever see that information itself. So we don't have to sanitize those. So we'll leave them till the end. We won't sanitize the stuff that's only displayed to the user themselves. Okay. So there was a lot of administrative panels and backend types of things that weren't part of a public profile. So it seemed kind of pointless to try and spend a lot of effort sanitizing those inputs. Since it's not like, even if I set it to be some scripting, you're never going to see that script because it's only going to be displayed to me. I could see it, but then I'm attacking myself. Okay, so it's like a self-inflicting cross-site scripting attack. Okay. Now, what adversaries realize is that actually, even if it's a sort of self-inflicting cross-site scripting attack, we can still weaponize it and use it against other users. And we can do it using a combination of cross-site scripting and cross-site request forgery. Okay, so this is the flow of the attack itself. We have a user and she has to get lured to a bad website. So this is evil.com. It's the adversary's website itself. Okay, so this is how it's going to work. And so how that happens, I'm not sure. Maybe a phishing. You click on a bad link, something like that. But this attack would involve you getting lured to a website. Now, normally, if you go to a bad website, the web model is set up in such a way that bad things shouldn't really happen to you. It should be safe. Not that you want to maybe test the limits of that, but in general, bad things shouldn't really happen to you just because you went to a bad website itself. Okay. Okay, so this is how the attack would work. So what will happen is the adversary will load an iframe. They'll point it at the social media profile they'll just point it to the social media profile. And what the browser will do is it will go load that social media profile. Because this is Alice's computer or her browser, if Alice is logged into the social media, then her cookie will get sent with this iframe request. And what will get populated in this iframe is her actual profile itself. Okay? Or whatever it gets pointed to by the adversary that's loading the iframe. Okay? So the adversary can create an iframe and say, go load this URL. And if it's the URL that corresponds to your public profile, or say your private, like where you would set your profile details, that's the website that would get loaded. Now, because of iframe isolation, this isn't dangerous because, even though the adversary is controlling the outer website, again, they can't reach into the iframe and say, read the contents of your social media or try and change things or try and get JavaScript running in the context of the social media. Okay. So the iframe is isolated from the outer website itself. Okay, but what the adversary can do is, so this is just showing that they can't reach in directly into this iframe. But what they really want to do is they want to be able to do that. They want to, for example, they want to read everything. Say this is your email inbox or something like that. They want a copy of all the emails that are sitting in your inbox. Okay, so what they'll do is they'll load a second iframe. Okay. And what the iframe will do is, assuming that, with RESTful architectures, that you're able to, you're able to say sign a user out just using URL parameters, then what they'll do is they could make an iframe like this, okay? So the source would be twitter.com/profile sign out equals true. And we'll assume that if Alice runs that, again, Alice's cookies go along for the ride. So Twitter knows that it's Alice, and then it will sign Alice out. So she's now logged out. Then what the adversary can do is they can load a third iframe. And these are in order. So you have to load this iframe first, then this second iframe, then this third iframe. You can do that with delays. So you can have JavaScript, wait a few seconds before it loads the next and wait a few seconds before it loads the next. And again, we'll assume that the adversary can use URL parameters to, say, log themselves in. So they'll pass the username and the password for their own account into the URL. Alice will execute it. People I sign out of social media on my computer and then maybe log in with a different account. So Twitter's not like it's strange that someone logged out and now they're logging in with a completely different account. That's normal. It's not an unusual thing to happen. And so what they'll do is they'll log in the third iframe, the profile of the adversary. Okay, so we have 3 iframes. Now, once this first iframe loads, unless if you explicitly refresh it or something like that, the content is just going to sit there. Okay, so Alice's content is still sitting in the first iframe. These iframes just log the adversary out and then log the adversary into the adversary. Sorry, they log Alice out of her account and then they log Alice into Alice's browser into the adversary's account itself. Okay, now you don't necessarily have to do it in 3 different iframes. This is just to make it sort of simpler so that you can see it. Then we're going to assume that the adversary did one of these self-inflicted cross-site scripting attacks where they found some field where they were able to put an input in. They were able to put a script in instead. And when the browser goes and looks at that profile, they execute the script instead of treating it like text. So it's a persistent cross-site scripting. The trick, though, was that it was on something that would only ever be displayed to the adversary themselves. It's not a public profile. It's part of their private profile. But because they logged Alice into their own profile, then they can make Alice look at that profile. Okay, so that's the real trick here, is they're getting Alice's browser to look at a profile that Alice should never see because it doesn't belong to her. It's not her account. It's the adversary's account. Okay, so they're making Alice look at the adversary's account. The adversary's account contains a cross-site scripting attack, persistent, and therefore Alice executes it. Okay, now what happens here? So a JavaScript that's malicious starts running in the third iframe. Okay, the question is, can it reach from the third iframe into the second iframe, or reach from the third iframe into the first iframe? Are these iframes isolated from each other? We said they're isolated from the main website itself, but are they isolated from each other? So to answer this question, we have to answer, well, what's the origin of all of these resources? So the origin of the outer website is evil.com. The origin of the inner iframe is twitter.com. When you load a second iframe, it has origin twitter.com as well, and the third iframe will also have origin twitter.com. The fact that they're in 3 different iframes doesn't matter. The browser all it does is it tags resources. So it just says there's an iframe, it belongs to twitter.com. Oh, there's another iframe, it belongs to twitter.com too. It puts it together as resources that belong to twitter.com that the user is currently seeing on the website. And so the script that's running in the third iframe absolutely can go and it can ask the browser, okay, there's another iframe. It has the same origin as me. So can you tell me everything that's there, right? Tell me all the images and all the text and all the resources that are there. Then it could package it up and maybe send it off to a server. JavaScript can open an internet connection to anywhere else. And so it could kind of siphon out all of the information from the first iframe and send it off. Okay. Now iframes also, here I showed it as an actual frame where you can kind of see what's going on inside, but iframes can be 1 pixel by 1 pixel. So the user like has no idea what's happening. They just go to an evil website, and there's a 1 pixel by 1 pixel iframe that corresponds to Twitter. So they don't. It's not like they see their Twitter load and then it logs out and then they see someone else's log in. Like they're not seeing anything. There's nothing to see. Okay, it just happens automatically. And here I depict it as they're just loading one sort of screen of Alice's, but in truth they could load multiple screens, right? So they could load a bunch of messages, the inbox and things like that. And then once everything is loaded in the one iframe, then they can play this trick to basically siphon the information out into the third iframe. Okay, so this is an elaborate attack, but at the same time it sort of shows you the extent that people will go to, adversaries will go to try and attack websites. Okay, so we call this self-inflicted cross-site scripting because you're running a cross-site scripting that only you are supposed to see, but we were able to weaponize it into tricking, like attacking Alice with something, even though that it was stored in our own profile and we were the only ones that were supposed to see it. Okay, here's another kind of attack. So here, let's say that Alice goes to evil.com. So they're on a website. There's an iframe. The iframe is loaded. Inside, there's a like button. And what the adversary really wants is they want to click that like button. Okay? Can they reach in with JavaScript and click that like button? Okay, so we already answered this and we said no. They cannot. Why can't they? Because the frame has a different origin than the outer website itself. So the outer website has origin evil.com. The frame inside has origin facebook.com. And so they're not able to use JavaScript to virtually, reach in. When I say reach in and click it, I don't mean like an action with a mouse or something like that. I just mean, if there's a button, when you click the button, all it does is it sends a message off. So they just have to construct that same message, but they're not going to be able to do it. Okay. So what can they do instead? Is there some way that they can get Alice to click that like button, even though they're not able to do it themselves, given that they control the outer website itself? So the answer is there is at least one way. What they could do is they could take an image, say like claim prize, and they can try and overlay it over top of the Facebook like button. Okay? And the idea here is they're going to try to entice Alice to click on that button, not knowing that there's a Facebook like button underneath. Okay? Now, is a website allowed to do this? Are they allowed to have an iframe and then overlay content on top of an iframe? And the answer is yes. So web standards permit that type of thing. So you can have an iframe. You still control the website. I'm on evil.com's website, so they can do all sorts of graphical things that they're allowed to do. And one thing they can do is they can sort of overlap things on top of each other. Okay. Now the next question is, let's say that Alice actually clicks on this. Is she actually clicking the like button? I mean, the browser is going to be confused because there's sort of a button on top of a button, or maybe this is just an image. But normally if I click an image, like it doesn't do anything, right? And so if I click in this region, the easiest way of thinking about it is, let's say that you put two buttons on top of each other. The user clicks. Which button gets clicked? The top one, the bottom one, both of them, none of them? How do you handle, if you're able to overlay things on top of each other, and when you click, how do you figure out what's actually getting clicked? Okay, and so what the standards allow is they allow the website creator to specify that. So the website creator can choose. Okay, they can't control Facebook. So the like button inside the iframe, they don't have any control over. But this claim prize that they put over top of it, they do control it. It's a resource that belongs to evil.com, not to facebook.com. Okay, and so the other thing I want to emphasize is that, when I drew the iframe and I'm like, you can't reach inside or reach outside, it kind of gave the picture of like the iframe being a border a graphical border where you can't reach inside or reach outside of like the pixels that are inside of this square. But the iframe is more of a logical border. It just says that all the stuff that's running inside the iframe, you're not allowed to touch. Okay, but it's not a physical border in the sense that you can't, you can't put things over the pixels that you've allocated to this particular iframe itself. Okay. So anyways, back to the clicking. So the user controls this button. Sorry, not the user, the adversary that's creating the website. And so there is an option to make what's called a transparent click. So the click is transparent. What that means is that if the user clicks on it, it just ignores the fact that there's a resource there that's being clicked on, and whatever's underneath will actually get clicked. Okay. So what will happen is, let's say that Alice is logged into Facebook. She clicks on the claim prize. She doesn't know that there's a like button underneath, okay? But her click goes through the image. It clicks the like button. If Alice is logged into Facebook, then her browser is going to make a cross-site request to Facebook. Her cookie is going to go along for the ride. Facebook's going to say, I know who this user is because I know the cookie value. This is Alice. And it already knew who it was when it put this, when it actually populated this, when she first loaded the iframe. But anyways, it's going to say, okay, this is Alice coming back. She just clicked the like button. So I'm actually going to update her profile. And, if it's configured so that every button that she likes, or sorry, every article that she reads online that she likes, it's going to be added to the list of accounts. And then the number of likes for this article, for as far as the adversary is concerned, it will go from 91 to 92, which is good for the adversary as well. Okay, so this is, we call this click jacking. So it's another attack. It's a way to sort of try and get around the cross-site, the same origin policy, but it's sort of a side channel attack because you're using graphical layouts instead of using code. All right, so that was all I wanted to say. So I want to give you some sort of parting lessons from just thinking about the browser policies, both the cookies and the same origin policy. So the first thing is it's sort of hard to get policies right. You've seen that. Also going back to the airport policies as well, airport security, it's easy to have like loopholes in the policies. Once you implement a policy, other people have to follow it. They need to understand what the policy is. So they have to have the right mental model of what that particular policy is. So the same origin policy isn't a bad policy. It's actually it's probably the natural policy. The problem with it wasn't that the policy was wrong. The problem with it was that developers didn't understand the policy. So they thought the policy was different than what it was. They coded websites up in such a way that they were interpreting the policy different, and then that's what caused attacks and problems. Policies in general, there's no great methodology for doing analysis. It's not like code or software where you can, do static analysis, or cryptography where you can do mathematical security proofs and things like that. If someone's like, here's the policy, it's really hard to analyze it. The one exception to this I mentioned after the airport talk is you could try to take the policy and turn it into code, into like a series of logical statements. Then you can try and use software to try and go through the policy now that it understands it from a logical perspective, and it can try and find vulnerabilities. So this exercise was done exactly for the same origin policy. So there's a great paper. I should have it in the slides. I don't. I forget. I think it was Adam Barth and Colin Jackson who did a lot of stuff on this. But anyways, they in the paper they use a modeling software. The name of it escapes my mind at the moment as well. But they model the whole cross-site scripting the whole same origin policy as implemented by a major browser. And then they ask the reason, there's like a logical reasoner, and they just say, okay, make sure that it's really impossible. Like something that's in an iframe can never reach out of that iframe and interact with the outer website. Or there's a bunch of axioms like that should be true if the policy is true. And what the model found is it found there were all sorts of weird conditions and corner cases and edge cases where there were violations of these axioms. Okay, so there was a weird combination of things that would come together, and then all of a sudden, things weren't isolated that should have been isolated. They found lots and lots of bugs in it. They fixed them all, so it was a good exercise, to do. Another thing is that once you set a policy, sometimes it's hard to change it later. Okay. So now that we have the same origin policy, now that cookies work a certain way, it's hard to you're going to break legacy websites if you change policies. Now, browsers will do this in extreme cases. So cross-site scripting was an extreme case. And so, for example, they made it so that you cannot load scripting over HTTP as opposed to HTTPS. That was a change they made. Yes, it did break websites. There were websites that were loading scripts over HTTP. Now when the user goes to those websites, the scripts don't load, and that's going to break the functionality of the website. And browser said it doesn't matter, like the security is paramount in this case, right? For cookies, for a long time we had third-party cookies. We had cookies that were cross-site cookies as well. And a lot of websites relied on that functionality. And then browsers came along and they said, you know what, we're just turning third-party cookies off completely. And the default setting is going to be that we're not even going to allow cross-site cookies either, unless if a user explicitly allows it. Okay. And so that's going to break some functionality of websites, and that's too bad, right? We need to improve the security. Then there were, so there's other examples of changes that were made. But in general, when browsers do these changes, they often advertise it years in advance, right? They say, okay, 2027 is the year that we're going to implement this change. You have 2 years to change your websites, and if you don't, then it's going to break. Another thing is that developers, this is something we saw in usability as well. Users, security is a secondary goal. You want the thing to work right. And then once it's working right, then maybe you think about security after it. And so developers also will do things like set origin to be the most permissive thing possible, set their cookies up to be the most permissive level possible. And, essentially, if you just want to get things to work, you're going to use a lot of overrides and things like that in order to do it. And speaking of overrides, every time you have little exceptions, it's okay, iframes can't talk to each other if they're from different origins. Oh, but developers want them to, so we're going to add this override. Now you have extra complexity. So now the policy is a lot more complicated because it's no longer that they cannot talk to each other. It's they can talk to each other in this one circumstance, but generally they can't. And then it becomes even harder to understand what the policy is, and it becomes harder to try and validate it. So complexity is kind of the enemy of security in this case because it allows for weird corner cases or edge cases that you might miss. All right, so that's what I wanted to say about policies themselves. And so I'll see you all next week for the next lecture.